Hi. So for question 2, we've been told a particle P of mass 0.5 kilograms is on a rough plane, inclined at angle alpha to the horizontal, where tan alpha is equal to 3/4. The particle is held at rest on the plane by the action of a force of magnitude 4 newtons acting up the plane in a direction parallel to a line of greatest slope of the plane, as shown in the figure above. The particle is on the point of slipping up the plane. Find the coefficient of friction between P and the plane. Okay, so for this question, we've been asked to find mu, which is the coefficient of friction. So the first thing I would do, as with any other maths question, is to draw a nice big diagram. Okay, and if you're in the exam, you can ask for extra paper, that's no problem. They'll just attach it to your answer booklet. Okay, so the first thing I'm going to do is I'm going to redraw this force of 4 newtons. Okay, so I'm going to draw it acting from the particle, acting out of the particle, okay? Just so I can keep things consistent with all of my other forces, so that they're all acting from the particle, acting either downwards or down the plane or perpendicular to the plane. Okay, just so I can keep some consistency. Okay, so we haven't been told the exact value of alpha, but we have been told that tan alpha equals 3/4. So what we could do is we could inverse tan both sides of this equation and find the exact value of alpha, but that may be a decimal number, which could lead to rounding errors when we use sine alpha and cos alpha when we start to calculate the components of different forces. Okay, so what we're going to do is find the exact value of sine alpha and cos alpha. Okay, so what we can do now is we can draw another little diagram here off to the side of our slope, angle alpha. Okay, so we know that tan alpha is 3/4, and we know that tan is the ratio of opposite and adjacent. So we know the opposite side to the angle is 3 units and the adjacent side is 4 units. Okay, so we can calculate the magnitude of the hypotenuse, and that will come out as 5 units. Okay, the square root of 4 squared plus 3 squared. Okay, so now what we can do is we can calculate the value of sine alpha, because we know that sine alpha is the ratio of opposite and hypotenuse. So we know that sine alpha is 3/5 and cos alpha is the ratio of adjacent and hypotenuse. Okay, so sine alpha is simply 4/5. Okay, so now we have exact values of sine alpha and cos alpha. That's going to help us for the other parts of the question. Okay, so back to my diagram now. I'm going to start to draw in all of the different forces. Okay, so the weight always acts downwards, and the particle has mass 0.5 kilograms, so its weight is therefore 0.5 g newtons. Okay, my next force I can start to think about is the normal reaction. Okay, so the particle is not falling into the slope, so there must be a force which is keeping it on the slope, and that is our normal reaction. Okay, and that's acting out of the slope, r newtons. Okay, so what I can do now is I can start to resolve the weight to find components into the slope and down the slope. Okay, so I'm going to resolve into the slope and down the slope. Okay, 2 components of the particle's weight. I know that this angle is alpha, and you can prove that in your own time. So the force that includes the angle is cos, so I know this force is simply 0.5 g cos alpha newtons, and the force that does not include the angle is sine, so I know that this force is 0.5 g sine alpha newtons. Okay, and I know that there is an additional force, and it's the frictional force acting downwards. How do I know it acts downwards? Well, the trick is in the question. The particle is on the point of slipping up the plane, so it's just about to move up the plane, And I know that friction always opposes motion, okay? So the particle's intended motion is up the plane, so friction will be trying to stop that and pull it back down, okay? So I know we have a frictional force acting down the plane as well, okay? So what I can start to do now is I can just start to resolve. Okay, so the first thing I'm going to do is I'm going to resolve perpendicular to the plane, taking this direction as positive. Okay, so I'm going to stick to one sign convention. Now I get asked a lot of questions by students, how do I know which way to resolve? And the answer to that is always the same. It does not matter as long as you stay consistent. So I'm always going to keep all forces that are acting away from the plane perpendicularly positive, and vice versa for forces in the other direction. They're going to be negative, okay? So with that being said, R is positive because it's acting away from the plane, minus 0.5 g cos alpha, and this equals to 0. Applying Newton's law of motion, I know that the sum of forces is equal to mass times acceleration, and the particle is not accelerating at all, in fact, not just in this plane. So the acceleration is 0. That's why the sum of forces is equal to 0. Okay, so what I can do now is I can add 0.5 g cos alpha to both sides. I'm going to rearrange for r. So r is equal to 0.5 g cos alpha. Okay, and I'm just going to label this equation 1. Okay, so now the next thing I can do is I can resolve down the plane, keeping this direction as positive. Okay, so I know that friction is acting down the plane, it's positive, plus another positive force again acting down the plane, 0.5 g sine alpha, minus that 4 newtons, the force that was given in the question, because that's acting up the plane. Okay, and again, this is not accelerating, so the acceleration is 0, hence the sum of forces is equal to 0. Okay, but if it was accelerating, it would be equal to mass times acceleration. So I'm now going to Q layer 1. So we know that friction is equal to mu r, where mu is the coefficient of friction and r is the normal reaction. So I can substitute this equation into here. Okay, so I know that F is the same as mu r. Okay, so I can replace F with mu r. Okay, so now if I rearrange for mu r by minusing this term and plussing this term on both sides, so I can isolate mu r, and we get minus 0.5 g sine alpha plus 4. Okay, so now I can divide by r, so I can get mu by itself because we want to find mu. So mu is equal to minus 0.5 g sine alpha plus 4 over r. Okay, and I can call this equation 2. Okay, so I know the value of r from equation 1, so what I can do is substitute equation 1 into equation 2. Okay, so I know I'm going to substitute the value of r in, that's 0.5 g cos alpha. Okay, so now I can calculate mu. I know the value of sine alpha and I know the value of cos alpha, so I can just substitute those in also. So the exact value of sine alpha is 3 over 5, what we did at the start, and the same for cos alpha, it's 4 over 5. Okay, so now you can just put this into your calculator and you should get a value of mu which is 0.270 to 3 decimal places. Okay, so it's standard to give mu to 3 decimal places in M1 as a rule of thumb, or 3 significant figures, because it doesn't matter because mu is less than 1. So one more point I'd just like to add, Q layer 2, is that mu should always be between 0 and 1, okay? And it has no units because it's simply a ratio between frictional force F and the normal reaction force R. Okay, so if I rearrange for mu by dividing by R in that equation, you'll get mu is equal to F over R, and the units of force is newtons, and the units of normal reaction force is also newtons, so that they cancel out. Okay, so mu is just a ratio, and it's always between 0 and 1. So if you get something less than 0 or more than 1, you've done something wrong. Okay, but for now, I hope you followed. Thank you very much.